First of all, I would like to thank the program committee to uh, we are grateful to and to present our research work on this prestigious conference, international conference on NLP trends and technology. So our research is basically unveiling the power of tag using statistical parsing algorithm for natural languages, and these are the our research area. uh, I am Prashant Chaudhary and my colleague Pavan Kurariya also present here, and we are working in Center for Development of Advanced Computing, and this is R&D organization of Ministry of Information Technology, Electronics and Information Technology. And our area of research is natural language processing, machine translation, and trade joining grammar. So basically, this is the outline of the presentation. Firstly, background and motivation are introduction, research environment for statistical parsing, experiment and tribank, future scope, and conclusion and references. So, firstly, the background is actually we are working in tree adjoining grammar last more than 15 years, and this is basically proposed by Dr. Arvind Joshi, and this is basically based on paper early type parsing algorithm presented in 1975. This is very powerful algorithm for natural processing. So we have in earlier we have done research and presented our work on implementation of this algorithm. This is very complex algorithm, and actually there's a some actually limitation of this algorithm. Basically, we have developed parser earlier. The parser is software program that analyze the source language structure and tell us the what is the link between the these currently nodes. So tiered, this is very powerful algorithm, and we observed this is basically rule based algorithm. So the fundamental limitation is actually the we have to have a language expert team. We have to analyze extensively on each language, and after that we have created the tree bank, and on the basis of tree bank we have developed the parser for each and every languages. Mostly we have done our work in English to Indian languages in past, so we have faced this kind of problem. Okay, so but I would like to share you the brief about the complexity of algorithm we have developed. Brief presentation here. You can see that this is the graphical notations of the how parsing work. We have taken the exact parsing trees, and we have parsed this sentence. In the philosophy of Kashmir, population is very distinctive. So parser is working graphically. You can see the red graph, how this is the implementation of actually early type algorithm, where you can see the traversal of the parser, and we have picking the exactly right trees. And so the complexity of the algorithm NY6, and this is resource consuming, time consuming. So I am the my objective to show you the complexity here. So I'm moving ahead in my current presentation. So this is the basic motivation how to resolve this problem to resource creation, extensive effort, all these. So we have analyzed, um, we can develop the statistical model, and on the basis of the statistical model we have created actually probability model. I will like to give it ahead. So we have developed the basically statistical parking algorithm, and we have this is the make use data driven model to identify the syntactic dependencies. We observed this using this probability model along with limited data set significantly improve the quality and performance existing parser. So we have developed firstly the array type conventional parser, and we have introduced the modern algorithm statistical model to improve this algorithm. So we have used to facilitate translation from one to another language. Basically we have translated English to few Indian languages over this using this algorithm. We have developed the H1 and H2 model. This parsing model is based on basically H1 and H2. H-mid model serve as a tagging probability model responsible to determining the most appropriate tree. Actually, in tree adjoining grammar, you have to be picking the right tree is the basic objective, and we have certain trees there, and during the adjunction and substitution principal operation. So on the basis of each node, there is a certain tree that candidate to be adjunct there. So at that time, the decision is picking the right tree is the most importantly. So we have created the basic probability model. This is the basic flow of the parser. Basically, this is natural language parser. You can translate any language from using this parser. This is input is here, then H1 H2 model is here. We train the H1 H2 model, and after that we use the training corpus, grammar rule, lexicon repository, or all these things. So I'm just focusing on the training H1 H2 training model. So here's the H1 model. H1 model is the actually probability model that train using the parse derivation. We already have some certain already parsing structures. So we have already analyzed these parse structure is correct. So we train this model by using these parse structures. And after that, S2 model, this is the purpose of estimate to determine the probability tree, actual candidate tree, what are the tree available, and actual the node where this tree will be the highest probability to be adjunct or substitute there. So we use the S2 model. The basic flow of the S2 model is uh, using the initial trees, auxiliary trees, the set of all these trees, and we use the language created language model using the 5-gram model set, and we use the schema and syntactic dependencies, all these analyze. So correct, I'm going to the exact research environment for the parsing and generation now. So this is basically the virtual research lab we have created in our earlier research, and we also presented paper on this. So we use this research lab to for the analyze the basically and doing the all research related to tree adjoining grammar. So basically this is graphical complete visual environment where you can just create the tree, analyze the tree, which visually analyze the parsing, all these stuffs. So we use this research environment, and our language expert team has created multilingual tree set we used in this research. So this is the basically the tree creation facility in visual environment. And after that, the basic application I would like to tell you now. We have taken for the example one simple sentence to parsing how will parse by using this statistical model. So we this is the basically input sentence in English, and this is the pre-processing of the cleaning, basic cleaning, all pre-processing stuff in input sentence. After that, we will do the post tagging, and CDEC also have some certain level of post tagger. So CDEC has not we can use the open source tagger also, and CDEC also have some tagger. So we both the tagger we have used. So after that, we have applied the all the tree. This is the basically each and every tokens has certain categories. So we division the each and every tokens, and each tokens and lexicon has certain like tree set. So you can see like preposition, that is the place of the first index, and after the noun, we have certain trees over there. These tree during the parsing will be useful, like these are the basically basic parse derivation. So each node, earlier I also visualized the I also demonstrated one parsing algorithms. So on the this is the final parse derivation will be constructed by using the algorithm, and we can say this is the past derivation which each and every node will be traverse. There is a four step of traversal dot traversing. This is also mentioned in earlier type algorithm. The only enhancement we have done in this during the travel, we have a statistical model. By using the statistical model in each node or each node, there is a four dot. Uh, each dot we can analyze the probability. What are the probability like and this is the tree where what are the probability in this tree to some other tree will be adjunct or substitute. suppose there are four candidates, each candidates has some probability, so which is the highest probability will be first will be given the chance first. So this is some kind of ranking we have done by using the statistical model. So this is the basically translation parsing generator, and finally we can construct the uh, parse generator in target language. Here is we have taken the Hindi language, but this language can be any Indian language. So currently we have done 9 to 8 languages. In Indian languages we analyze this, and this is the inner picture of the parser what are already telling you. This is suppose one tree, then there is one node is LA, then LA is the prediction happen, and suppose this there is a certain tree, suppose these two trees, each tree has some probability, and so the tree will be qualified that is has highest probability. So we have done the tree bank we have already created by our tree bank. For this experiment we have created the virtual machine, and various tests has been analyzed by using different Indian languages like English, Hindi, then English, Marathi, then English, Gujaratis, all these languages we have done. And this is basically uh, our tree bank. We have in some languages like English to Hindi, we have tree bank like 150 trees. In some other languages like Marathi, we have 175 trees. Then these are the tree for English, and also in target side we have used the trees. So this is basically the experimental setup. We have taken the Linux quad-core Intel Xeon processor, then JBoss application servers, and backend we have used the MySQL 6.0. So this is basically experimental survey. In final experiment, we have used the set of 8,000 gold sentences. This is English and target language references. We have taken English to Hindi, so we have references for this. In average length of the sentence is 25 or less word. So out of 8,000 sentences, say 7,500 sentences were trained by using the H1 model, and out of 500 sentences, 5,430 sentences be trained and parsed and correctly generated. So this is the speed of the parser. In some other experiment, we analyzed this. We have given the 11,000 sentences, random sentences, and parser taking the 3 minute 45 sentence to parse these 11,000 sentences. So this is the speed improvement in terms of earlier type of algorithm, because now the trees are limited, so parser is taking less time. We also analyze the memory consumption and all these stuff during the experiment. So the future scope is this key. We have also have extensive research what are the techniques modern researcher, NLP researcher is doing. So currently the NLP is very neural network is very hot topic. So we have also at initial level we have investigated tree adjoining grammar with neural network. We have created some neural network by using our parse derivations, but this is in very initial stage, and this neural network in future we will explore, and this is capable to capturing the linear relationship, long term distance relationship. This is the fundamental problem in currently we have facing in tree adjoining grammar based parser. So all these things in future we will do work on neural networks and in tag. And conclusion, this in this paper we firstly describe the original definition of tree adjoining grammar. We have implemented the early type tag parser. We have also studied, analyzed the effort by various researchers in advancement of existing early type algorithms, and we propose the advanced and modern mechanism of using the statistical model with the probability calculations, all these formula, and that this model is we have analyzed in our experiment is working better than our early type algorithm. So we have demonstrated end-to-end statistical parsing algorithms, and we have used this algorithm or this parser in our machine translation application, and this application is working in English to various Indian languages. So currently we are, but this parser can be used for other work also, like analyzing the large text, large corpus, analyzing the syntactic dependency, information extraction, semantic, and all these stuff this parser can be used in future. And these are the references or our guiding lights. So these fundamental algorithm is based on Arvind Joshi. Then our earlier work also influenced this research, and the Sarkar research three adjoining grammar application statistical parsing are so very useful to us to defining our model and all these processing. So we are very thankful to this, and thank you very much. This is the our presentation, and now I would like to
You.
invite the yes.